Swayam Prabha. Digital India. Educated India.
So, I will make you understand what is the mistake that I have committed in step 3. In step 3, basically what we did, u1 hat equals to gamma 0 plus gamma 1 u2 hat plus epsilon. That is the equation we have specified, right. Now, if you recall, one of the properties of our sample regression function, if you put x here and y here, then we say that, say this is y bar and let us say this is x bar, then we say that sample regression function must pass through the origin. That means, this is basically x bar y bar. Okay. This is the property that sample regression function must pass through the sample mean or average. That means, here when I am running a regression of y on x, it should pass from x bar and y bar. That is one of the important property that we have discussed. This is the SRF. Now, in this regression, what we are doing, if you replace x by u2 hat and your dependent variable here is u1 hat, then that should also pass through the origin. So, that means, this should be u2 bar and u1 bar. So, that should also pass through the sample average, okay, sample average, all right. Now, my question is, what is the value of u2 bar and u1 bar? If you recall, one of our assumption what we mentioned, that expectation of ui given xi equals to 0. Okay. If that is the case, following this assumption, we can say that u1 bar equals to 0 and u2 bar is also equals to 0. And that means, this is the coordinate called 0 0. So, that means, this intercept should not be there in this equation. So, that means, when you are running a regression of y2 u2 hat on u1 hat, that regression must pass through the origin. This point is 0 0. So, that means, this intercept should not be there. If the intercept is there, that means, that cannot be the coordinate of 0 0. Okay. So, that means, in this equation, when I am specifying, this term should not be 0, should not be there. So, our equation would be u1 hat equals to gamma 1 u2 hat plus epsilon. No intercept should be there, and that is coming from the property, one of the important property of the sample regression function, that sample regression function must pass through the origin, right. And then, since u2, u1 and u2, they both have 0 mean, the sample average of u1 and u2 is 0 and 0. So, the line must pass through the origin. There should not be any intercept term exist, right. So, this is basically the theoretical portion. That means, this is the theory of how to keep the impact of other factor constant, right. Now, these steps what we have learned now, we will try to perform using the data set. Okay. So, this is the data what we are getting. Look at this. So, first I will show you the data. This is the data. this is child mortality rate, this is female literacy rate, this is per capita GNP, and this is total fertility rate, some other variable, and we have state level data of 64 states. This is the state level data. Okay, this is the state level data. So what we will do now, we will try to follow that step. So we have child mortality rate, FLR and PGNP, and we want to get the net impact of FLR on child mortality rate. So step 1, what we need to do? We need to run a regression where the dependent variable is CM and independent variable would be PGNP, because we need to remove the impact of PGNP from both CM and FLR, right. Since we are interested to get net impact of FLR, we are eliminating the impact of PGNP. So first step, we are removing the impact of PGNP on CM. How to do that? We will run regression reg CM on PGNP. This is how we will run the regression. Okay. All right. You can easily interpret these coefficients also. See, there is a negative relationship between per capita GNP and CM. As income of a particular state increases, child mortality rate decreases by 0.01 unit on an average, which is expected also. As income increases, people become more aware, people take good food, good rest, and they give proper care in terms of medicine, so on and so forth, and as a result of which child mortality rate goes down. So once we estimate this model, then what we need to do from this regression, we need to collect the predicted value of the error term. Now, to collect the predicted value of the error term U1 hat from this regression, what we need to do? We need to put a specific command, right? We need to give a specific command, and the command is very simple. I am writing the command also. The command is predict and then you have to give some name. Predict command is always used for predicting something. That means when I am writing U1 hat, U2 hat, Y hat, the hat means the predicted value. That is why predict command. What you are predicting? Some name you are giving. Predict U1, okay? Predict U1, comma, what is U1 basically? Residual. This is the command, okay? Similarly, for U2, predict U2, comma, residual. This is the command. So now we will put this command here. We will say this is predict U1, comma, sorry, comma, SIDUL, predict U1 residual. Now, the moment I put the command, STATA will immediately predict the U1 hat, and look at here, U1 is already included as a variable now. Whether it is predicted or not, how will you check? You just look at in the variable list. If the variable is appearing, that means STATA has already predicted the variable and stored it also. Now, what is the next step? In the next step, we need to remove the impact of PGNP on FLR. So, again reg, then we need to run FLR, regress FLR on PGNP. This is how, okay, and the impact is, look at here, positive. That means as per capita income GNP increases, FLR also increases, female literacy rate, and the variable is significant at what percentage level can you think of from the p value? P value is 0.032. So, if you multiply this value with 100, what will come? 3.2, which is greater than 1 but less than 5. That means this PGNP is significant at 5% level. This is how you have to interpret this coefficient. So, again from this we need to predict, and same command PRE DICT predict U2, and then you put RESIDUAL residual. Okay. So, once you put this command, then STATA will immediately predict the residual also, alright, residual also. And how will you check whether it is predicted or not? Look at here, U2 is also included, okay, U2 is also included. Now, what we have to do? We have to run a regression. That means in step 3, U1 hat is regressed on U2 hat with no constant term, okay, with no constant term. And what would be the command for that? In step 3, reg U1 on U2, and you need to specify STATA that I do not want any constant term. And what is the command for that? We need to specify no cons, no cons. This is the command in step 3. Okay, this is step 2, this is step 3, step 1. Okay, step 1. In step 1, we will regress and then we will collect this. So, in step 3, what we need to do? We will regress U1 on U2, and then we will put no cons. Okay. So, what is the coefficient here? Coefficient of U2 is minus 2.231. So, that means for a unit change in U2, U1 changes by minus 2.231 unit on an average. But then what is this? What is its relation with the original equation? Since U2 hat is basically the purified value of FLR and U1 is the purified value of child mortality rate, or we can say that means the interpretation of this would be when FLR increases by 1 unit, then child mortality rate decreases by 2.231 unit. So, U2, this 2.231 is basically the net impact of FLR on child mortality rate. Since this is negative, we can say that female literacy rate and child mortality rate, they are negatively related, and which is very true also. As we said in the beginning, that as female literacy rate increases, then mothers become more aware of what type of proper care they need to take during pregnancy and after delivery, child mortality rate will decrease. That is why the negative sign. So, this is how step by step we can, this is the step by step procedure what we should follow to keep the impact of other factor constant. But that does not mean that whenever we want to get the net impact of a particular variable in a multiple regression model, we will follow all these steps. No, that is not required. Rather, at a single step itself, we can get the net impact. That is the beauty of the statistical software. How to do that? What was our original model? Our original model was Cm equals to beta 0 plus beta 1 FLR plus beta 2 PGNP. So, if you specify that regression, how will you specify? Reg, then FLR our dependent variable was CM, then independent variables were FLR and then PGNP. This is our complete model that we wanted to run, and if we run this, now look at the beauty. What is the coefficient of FLR? Minus 2.231. What was the coefficient what we got following the steps? If you follow, that is also minus 2.231. Okay, minus 2.231586. Here also minus 2.231586. So this coefficient is exactly following with the coefficient what we got earlier. Okay. So that means what we can say, that the theoretically what we have derived and empirically what we have estimated, they are matching. Okay. So multiple linear regression model, the coefficient what we get, that is basically the net impact. So the statistical software STATA actually doing everything for us. So that means all those steps, step 1, step 2, step 3, what we discussed earlier to keep the other factor constant, STATA is basically doing that, and STATA is supplying us directly the net impact of each and every variable. That is the beauty of this multiple linear regression model, and that is the beauty of this software. Okay, but we must know all these steps, what we actually should do to understand the interpretation of multiple linear regression model in a better way. If we do not know the steps, then we may not be able to appreciate what actually we are getting from this. Okay, this is how the multiple linear regression model is estimated. And then what we will do, as we have learned the hypothesis testing part and goodness of fit measure previously, we will try to understand all those results from here. First of all, what is the R square here? The R square here is 0.7077. What does it mean? Can you remember? Do you recall the meaning of R square? So R square is 0.7077. Okay. First of all, R square is 0.7077. What is the meaning of this? The meaning of this, as R square equals to all we defined earlier, R square is ESS by TSS, right? So that means we can say the meaning is 70.77% of total variation in CM is explained by FLR and PGNP. These are the two explanatory variables we have included in our model. So that means we can say that out of total variation, 70.77% of total variation in CM is explained by the two explanatory variable FLR and PGNP, and that is what the goodness of fit is 70.77%. So our model can explain 70.77% variation in child mortality rate. That is the interpretation of R square. This is the first thing we need to know. Then secondly, the significance of the explanatory variable. okay, significance of the explanatory variable. How will you check? So, first of all, FLR, what is the t value? Minus 10.63, minus 10 point. So, FLR corresponding to FLR corresponding to FLR, the t value equals to minus 10.63. So, that means what we need to do? We need to take modulus of this, so would become 10.63, and this is called calculated t value, and this we should compare with the tabulated one. And what should be the degrees of freedom? Total number of observation is 64, and as we said, the t will always follow a t distribution with n minus 2 degrees of freedom. So, that means 62 degrees of freedom and 5%, 1% and 10%. This we have to compare from the table. Okay. So, at alpha equals to 5%, we need to get the value. And since this is 10.63, even without comparing also any value beyond 3 or 4, by rule of thumb we can say that this would be, this calculated value would be greater than the tabulated one, and since this is greater than the tabulated one, we have to reject our null hypothesis. What was our null hypothesis? That here we can say that we have two null hypotheses. First one is beta 1 equals to 0, and second null hypothesis is beta 2 equals to 0. These are the two null hypotheses. So, that means neither FLR nor PGNP has any impact on child mortality rate. If this is greater than this, then we have to reject the null. We have to say that yes, FLR has significant impact on child mortality rate. This is by level of significance approach. Similarly, for the PGNP, what is the t value? Minus 2.82, minus 2.82. So, that means for PGNP, what is the value? Minus 2.82, minus 2.82. This also you take, then it would become 2.82, it will follow then t n minus 2 degrees of freedom, alpha equals to 5%, we need to compare. Since it is 2.82, we need to compare whether it is actually greater than the tabulated or not. So, that means going by these t values, we need to compare with the tabulated value. But as I said earlier, STATA is also giving us the p value, which is called exact level of significance. And look at the p value is 0.000 and 0.006 for PGNP. So, if you multiply by 100, both the values are less than 1. Okay, what I said? So, that means p equals to, first of all, 0.000 for PGNP and p equals to 0.006 for, this is for PGNP and this is for FLR. So, we have to multiply p with 100, and both of these cases this is less than 1. This is 0.0, this is 0.6, both are less than 1. So, that means using the p value, we can easily understand both PGNP, both the variable, both FLR and PGNP are significant at 1% level. So, following the p approach, we do not need to compare this tabulated with the calculated one. So, this is called level of significance approach. Now, what we will do? We will see the confidence interval approach. Confidence interval approach. Confidence interval approach. There, corresponding to FLR, What is the confidence interval that we got? The confidence interval is minus 2.65 to minus 1.81, minus 2.65, minus 2.65 to what is the value? Minus 1.81, minus, so this is minus 1.81. Okay. So, that means we can easily understand this particular interval does not capture the hypothesized value of the population parameter. What was the hypothesized value? Beta 1 we have hypothesized is 0. So, this interval does not capture 0. Okay. So, that means estimated interval does not capture 0. Okay. Then what is the implication? Reject, since the interval fails to capture the hypothesized value of the population parameter. So, reject H naught, which is beta 1 equals to 0. That means when we reject this, we will say that beta 1 is actually significantly different from 0. So, that means FLR has significant impact on child mortality rate. Then what is the interval for PGNP? PGNP's interval is minus 0.009 to minus 0.001. So, minus 0.009 to minus 0.001. This is the interval. Okay. This interval also, since both are negative, it does not capture 0. So, that means estimated interval does not capture 0. So, reject H naught, which is beta 2 equals to 0. And when it is rejected, we will say that even PGNP also has significant impact on child mortality rate. Okay. But following this interval estimation approach, we can only say that whether the variable is significant at 5% level or not, because this is 95% confidence interval. So, STATA will always give only 95% confidence interval. This is also 95% confidence interval. If we want to know whether it is significant at 1%, obviously if it is 5%, then automatically it would become significant at 10% also. It is absolutely no problem, as we said earlier. But whether it is significant at 1% level or not, to understand that, we need to construct the interval at 99% confidence interval. But following the p-value, we can easily say that it is significant even at 1% level. So, that is the advantage of using p-value over t and this confidence interval. Okay. This is how we can interpret the coefficients actually. Okay. Now, what about this ANOVA table? So, from this ANOVA table, again, as we said, this particular table is called ANOVA, analysis of variance. So, STATA is again supplying model sum of square, residual sum of square and total sum of square. So that means when the total sum of square is basically, total sum of square is this 3,63,678, that is called total sum of square or TSS. TSS equals to 3,63,678, that is summation yi minus y bar whole square. Out of this, how much our model is able to explain? 2,57,362.373. That is called ESS, or in STATA's language it is called model sum of square. Okay. And what is the remaining? Remaining portion is called residual sum of square or RSS, that is 1,06,315. So that means this minus this. Okay. And then again corresponding degrees of freedom. What would be the degrees of freedom for TSS? Total number of observation is 64, and we know that TSS degrees of freedom, once again I would like to revise you, that TSS is basically summation yi minus y bar whole square. Since there is only one restriction imposed, this is called degrees of freedom for TSS should be n minus 1. Okay, degrees of freedom should be n minus 1. And what is the degrees of freedom for RSS? RSS, how will you determine the degrees of freedom? The RSS equals to yi minus alpha hat minus beta hat xi square. That is how we have defined. Our model was yi equals to alpha plus beta xi plus ui. So I would like to remind you, before we estimate RSS, we must estimate alpha hat and beta hat. So we are putting two restrictions here in terms of alpha hat and beta hat. That is why degrees of freedom for RSS would be n minus 2. Okay, n minus 2. Or in general, we can say that this is n minus k, where k is total number of parameters to be estimated from the model. And then you can easily say that degrees of freedom for ESS, degrees of freedom for ESS would be n minus 1 minus n minus k equals to k degrees of freedom, where k is the total number of parameters. So in this model we have 3 parameters to be estimated. Okay, 3 parameters, alpha, beta and this constant term. That is why you see the degrees of freedom for model is n minus 1, sorry, this is n minus 1 64, and residual sum of square is 2. So that means n minus 2, sorry, n minus 61, because it is 3, n minus k equals to 3, 1 to 3, that is why it is 61. And if you take this, 63 minus 61 equals to 2. Okay, is this clear? K equals to 3 here, because 3 parameters we are going to estimate, 2 regression coefficient and 1 constant term. That is why RSS degrees of freedom is n minus k, where 64 minus 3 equals to 61, and then 63 minus 61 equals to 2. So this is how we have to understand the ANOVA table, which clearly shows the decomposition of total variation in our yi. Okay, right? But some of certain other measures which are also supplied by STATA, which is another F statistic. Look at the F statistic value, which is 73.83, and then another R square which is called adjusted R square. These things we have not yet discussed, right? We will understand the importance of F statistic and adjusted R square in our next class. Okay? So in our next class, we will discuss how to use these measures F statistics and R square, adjusted R square, which is also supplied by STATA. That will be discussed in our next class. Thank you.